Hi students, welcome to today's class. Today I am going to explain the solutions of the problems which belongs to greatest integer function. So today's class is exclusively greatest integer function class. Okay now? Right. Greatest integer function in the definite integration. So let us see the first problem. Integral 0 to n step of x dx. Here n is a natural numbers. Of course, step x is a greatest integer function. Okay. Then how to do this problem? See here, it is the integrand step x. It is a step x or mod x or signum x or fractional part of x. Its behavior will change from each and every interval. So if it is step x is there from 0 to 1 value, step x value is 0. From 1 to 2, step x value is 1. From 2 to 3, the step x value is 2. Like that, its behavior will change. That's why this type of problems you cannot do directly. Okay now, if it is simply x or simply x square, if it is sin x, if it is cos x, then you can do directly. Okay, but whenever it is step x is there, you have to divide this interval 0 to n into a certain number of subintervals. Okay now, then how to divide that certain number of subinterval? That depends upon the x value here. Okay, so afterwards I will tell if it is a root of x square, what is there. If it is simply x square is there, then how to divide, I will explain. Okay, here our integrand is of course step x, but inside step x, so inside step, what is there? Simply x is there. That's why we can divide this interval 0 to n as, see here how to divide. So this is equal to, I call it as it 0 to 1 step x dx plus 1 to 2 step x dx plus so on last step n minus 1 to n step x dx. Okay, so like that I divided the interval from 0 to n into some subintervals, that is 0 to 1, 1 to 2. Why? Because from 0 to 1 the step x value is, we know that. From 1 to 2 the step x value we know. From n minus 1 to n the step x value we know that. Okay, now what is the step x value from 0 to 1? 0 to 1. So we know that one very important property. If it k is less than or equal to step x less than k plus 1, sorry, if it is x, then step of x value is k. That means if your x value lies between k and k plus 1, the step of x value is k. That means if it is 2 less than or equal to x less than or equal to 3, then your step of x value is equal to how much? 2. Why? Because 2.1 step of 2.1 is 2. 2.5 step of 2.5 is 2. Understand that. Now coming to here from 0 to 1, what is the step of x value? 0. So this is equal to from 0 to 1 this is 0 plus from 1 to 2 this is a 1 dx plus so on. So this is n minus 1 to n, this is a n minus 1 dx. From n minus 1 to n the step of x value is n minus 1. So of course this will become 0. So you forget about this. Again coming to 1, take outside. Here 1 will be there. What is the integral of 1? X. It is x, upper limit, lower limit. So here, no, generally I didn't write here. So here if it is a 1 to 2, 2 to 3. So here what we will get? 2x dx. So 2 will come outside. So if it is a x and here upper limit, lower limit. Last one n minus 1 come outside. Why? Because it is a constant. Okay, for 1, what is the integral of 1? X, upper limit, lower limit. Okay, now the integral part is over. Now the simplification part is there. Now how to do this? So this is equal to 1 into upper limit minus lower limit, 2 into upper limit lower limit, so on, n minus 1 into upper limit minus lower limit. So this is equal to 2 minus 1, 1 plus 3 minus 2, 1, 1 into 2, 2 plus 3 plus so on So this is a n minus 1 into, see here, n minus n plus n minus will get cancelled, minus into minus plus. So what is the sum of n minus 1 terms? What is sum of n minus 1 terms? Yes, we know that sum of n terms is equal to, that means 1 plus 2 plus 3 plus so on if it is n. So we know that n into n plus 1 upon 2. If it is n, then n into next term n plus 1 by 2. If it is up to n minus 1, if it is up to n minus 1, that is equal to n minus 1 into, what is the n minus 1 next term? Plus 1, that is n by 2. Understand? So that is the sum of first n minus 1 term formula. Okay. So from this you have to remember one formula. So here onwards, wherever integral of 0 to n step of x dx value is n into n minus 1 by 2. So this is the formula. You have to remember it as a formula. Integral 0 to n step of x dx value is n into n minus 1 by 2. It is a formula. So it is a very nice and very easy problem. Why I am explaining this problem is how to divide the interval. So first to see the value of what is there inside the step. What is there inside the step? It is simply x. If it is root x is there, what happens? If it is root of x square is there, what happens? If it is simply x square is there, what are the limits that we have to take? Let us learn detailedly. Okay, now? So let us go for next problem. Welcome to this problem. Here the problem is evaluate integral 0 to n square step of root x dx. Of course, where n is a natural number, step of x is greatest integer function. Then how to divide this interval from 0 to n square? Already told that its behavior will change from each subinterval. Then how to divide this interval? See here, root x. Here x should be, if it is a root is there, it is a headache with the roots. Okay, roots are fractional parts, fractional powers, whole power 3 by 2, whole power 2 by 3. With that, we will get a headache. So how to remove that root? If x is a perfect square, that means if it is a 1 square, 2 square, 3 square, then we can avoid the root. Okay, now that's why you have to take divide this interval from 0 to n like this. Everybody knows. So that is equal to 0 to 1 square step of root x dx. Understand? Then 0 to 1 square means what? If you substitute here 1 square, root of 1 square is how much? Actually you have to write down modulus of 1. But the thing is here, 0 to n square all are positive real numbers. N belongs to n, he is saying positive natural numbers. That's why there won't be any question of modulus here. Okay, right. Again you have to take 1 square to 2 square root of modulus of step x dx plus 2 square to 3 square root x dx plus last but not the least n minus 1 whole square to n square step of root x dx. So this is the first step that you should get an idea. Why? Because here root x, x is 1 square. So root 1, 1. Understand? So 1 square to 2 square root of x. So root of x means here root x value lies between 1 to 2. Why? Because here 1 square, root 1 square 1, root of 2 square 2. That means here root x value lies between 1 to 2. Here root x value lies between 0 to 1. Here root x value, root of upper limit, root of 3, upper lower limit minus upper limit. Upper limit minus lower limit. If you substitute, its roots lies between 2 and 3, lies between 2 and 3. So that means 2 point something, 2. Okay. So then you will get here, so this is equal to integral 0 to 1 square. So here you will get from 0 to 1 you will get 0 to 1 how much? 0 dx plus integral 1 square to 2 square. From 1 to 2 root of step x is equal to how much? 1. That means equal to 1 dx. From 2 square to 3 square. So here how much you will get? 2 to 3. What is the step value? 2. 2 dx plus so on integral n minus 1 whole square to n square. So here what you will get here, n minus 1 you will get. Right. So here how much you will get? N minus 1. See here, if it is 1 square, 1, 2 square, 2. So here n minus 1 whole square, you have to get n minus 1. So now let us do this problem. So this value is 0. So forget about this. Why? Because here 0 is there. Take one constant outside, 1. So here nothing will be there, again 1. What is the integral of 1? X upper limit minus lower limit, that is a 2 square minus 1 square. Here take 2 common outside. 2 outside constant is take right out of the integral. Here 1 will be there. What is the integral of 1? X upper limit minus lower limit. That means 3 square minus 2 square plus so on. Take n minus 1 common outside. So this is upper limit minus lower limit. Okay. So almost the integration part is completed. Okay. Now we have to do the there is now again, to do this problem, we should have a fundamental concept grip over the sequence and series. So we got a series here. So we have to find out sum of n terms of this series. Let us see the first one. See here. So here 1 into 2 square minus 1 square, 2 into 3 square minus 2 square. So here n minus 1 into n square. Of course, up to here, how much here? So here n minus 1 whole square, expand it. If you expand it, how much you will get here? So this is equal to minus 2n, this is a plus 2n, plus 1 minus 1, you will get 2n minus 1. Now to do this problem, I am going to, it's a different methods you can apply here, but I will use the sigma notation here. So let us take the sigma. R runs from 1, R runs from 1 to n minus 1, right. So in place of n minus 1, I will write down R. If it n minus 1 is equal to R, so if it is n minus 1 is equal to R, then is equal to 1 plus R, 2n is equal to 2 plus 2R, 2n minus 1 is equal to 2R plus 1. So this is equal to 2R plus 1. Last term I am writing. So R runs from 1 to n minus 1. See here, let us check whether all the values we will get it or not. If R is equal to 1, it is a 1. 2 square minus 1 square, 4 minus 1, 3. 2 into 1, 2, 2 plus 1, 3, that we are getting 3. Next R is equal to 2, see here 2 we will get. 3 square minus 2 square, 3 square 9, 9 minus 4, 5. 2 2s are 4, 4 plus 1, 5. Last term observe here. Here in place of n minus 1, I have taken R. It is 2n minus 1. Therefore, n minus 1 is equal to R. Therefore, n is equal to 1 plus R. I want 2n. That's why I multiply with 2 on both sides. I want minus 1, subtract 1 on both sides. That is 2R minus 1. Now, we know that from sequence and series. So, this is equal to sigma. R runs from 1 to n. 2R into R, 2R square. That means n minus 1. This is a n minus 1. So, that is I can take 2 outside. This is R square plus sigma R runs from 1 to n minus 1. This is 1 I am getting. 1 means now, so this is equal to, see here, 1 square plus 2 square plus 3 square, so on. See here, n minus 1 whole square, not n square. What is sigma? Sigma n square value formula, that is equal to n into n plus 1 into 2n plus 1 upon 6. This is the value. That means if it is sigma n square, that means here 1 to n, sum of n terms, n into next term, n plus 1 into 2n plus 1 upon 6. Understand this. So here sigma r square is there. That means 1 square plus 2 square plus 3 square, so on, n minus 1 whole square. Then how to do that? How to do that means here n is there, but here n minus 1 should come. N plus 1, next term, that is equal to n. 2n plus 1. 2n plus 1 means what? Whatever may be the here, 2 into n plus 1. So here 2 into n minus 1 plus 1. So here n means what? Whatever may be the here, 2n plus 1. Here n minus 1 is there, 2n minus 1. So this is equal to 2n minus 1. So this is equal to 2n minus 1 whole divided by 6. Okay, now plus 1. Here 1 means what here? 1 plus 2 plus 3 plus so on n. Just a previous problem only I explained. What is sigma n? N into n plus 1 upon 2. That is n next term by 2. Here also what is the last term? N minus 1. N minus 1. What is the next term? N by 2. Okay. So you simplify this answer, you will get the correct answer. Okay. Almost the problem is over. So 2 1s are 2 3s are cancel. You can take the in the numerator n into n minus 1, you can take common outside. Again 2n minus 1, simplified it. So from this, whatever may be that up to here, the first thing what you have to remember to do this problem is how to separate these intervals. How to separate these intervals. So that observe the what is there inside the step function. Root x, root is there. Root should go. If what should, when root will go, when inside this x, it should be a perfect square. 1 square, 2 square, 3 square, then only the root will go. Okay, na? Right. I hope that you and afterwards observe here. This is writing this into sigma notation. Otherwise, you can do some students then can they can also there. Why? Because you multiply these two. N into 2n, 2n square. This is nth term is 2n square. N into 2n, 2n square. N into minus 1, minus n, minus 2n, minus 3n, minus into minus plus 1. Okay, na? So your answer is sum to n terms, sum to n terms. So 2 into sigma n square, n into n plus 1 into 2n plus 1 by 6 minus 3 into sigma n term, n into n plus 1 by 2, 1 means n. You can also simplify like this. You can also simplify this term also you can do. Otherwise, if you think in a logical way, this way also you can do that. Okay. I hope that you understand this solution. Let us go for next problem. Dear students, welcome to this problem. Integral 0 to 2 step of x square dx. Very nice problem. 0 to 2. Here inside the step function what is there? X square. 0 to 2 interval is there. Here x square is there. That square should go. That term. So maximum our intention is we have to make this as x only. So previous in the starting problem already it is x is there. Next problem root x is there. Now it is x square is there. If it is x square there, then what limits you have to take? Roots you have to take. If it is a roots, we have taken 0 to 1 square, 1 square to 2 square, 2 square to 3 square like that. If it is x square is there, then how to remove x square, whatever may be that square. If it is x is roots, then we can remove that square. Then we can divide this interval into integral 0 to root 2. If it is a root, sorry, 0 to root 1, 0 to root 1. So that is step of x square dx plus integral root 1 to root 2 step of x square dx plus integral root 2 to root 3 step of x square dx plus integral root 3 to root 4 step of x square dx. Observe here. 1 to root 1. If it is x is under roots, then root and square will get cancelled. If it is x is under roots, this root and square will get cancelled. You will get the answer. So root 4 means 2. Root 4 means 2. So this is a upper limit and it is a lower limit. Okay, na? So very nice problem. This is a, so from 0 to root 1. So that means whenever you are substituting 0, it is 0. Root 1 means 1. Root 1 whole square means 1. From 0 to 1, what is the integral value? This is 0 plus 2x plus integral root 1 into root 2. From root 1 to root 2, that means here 1 to 2. 1 to 2. What is the step of this value? You will get 1. 1 dx plus root 2 to root 3. From root 2 to root 3, what you will get? Root 2 whole square 2. Root 3 whole square 3. From 2 to 3, what is the step value? 2. That is 2 dx. Obviously, root 3 to root 4, 3 dx. Understand? So almost the problem is over. So this value is 0. Forget about this. Take 1 outside. Here 1 will be there. What is the integral of 1 is x. X means root 2 minus root 1 plus 2 take common outside, root 3 minus root 2, take 3 common outside, root 4 minus root 3. So, this is your final answer. Okay, now. So, let us simplify this. So, this is equal to root 2 minus root 1 plus 2 root 3 minus 2 root 2 plus 3 root 4. Root 4 means 2, 3 2s are 6 minus 3 root 3. So, here it is 6 is there, here root of minus 1 means 1, 6 minus 1, 5. Root 2 minus 2 root 2 minus root 2, 2 root 3 minus 3 root 3 minus root 3. So, this will be your final answer. So, observe here the pattern. So, previous problem x is there 0 to 1, 1 to 2, 2 to 3 we have taken. If it is root x is there, we have taken 0 to 1 square, 1 square to 2 square, 2 square to 3 square, like that we have taken. If it is x square is there, 0 to root 1, therefore the x will come outside. Root to 2 whole square, 2 will come, that means only x remains. Like that we did this problem. Okay, now, right. I hope that you understand this solution. So, now I am going to explain a very typical problem. Let us see that problem. For that problem, so the division of this intervals is a somewhat if you have the graphical knowledge of drawing the quadratic equation curve, then definitely you will get this, you will get the solution for that problem. Let us see that problem. Okay. Welcome to this problem. Evaluate integral 0 to 2 step of x square minus x plus 1 dx. This is once asked in one of the IIT JEE examination. Let us try to understand. So very easy problem. This is if you think in a graphical way, the problem will be very easy. First of all, what is the nature of the graph y is equal to x square minus x plus 1? Let us see the graph. What is that? Is a circular or a parabola, ellipse, hyperbola? Let us see that. Okay. So, this is equal to y is equal to x minus 1 by 2 whole square, x minus 1 by 2 whole square, that means x square minus 2ab, that means minus x plus 1 by 4. So, this is a minus 1 by 4 plus 1. Plus 1 by 4, there 1 by 4 you will get. Then y is equal to x minus 1 by 2 whole square, 4 1s are 4, minus 1 plus 4. So, this is equal to 3 by 4. So, now this is equal to x minus 1 by 2 whole square, y minus 3 by 4. So, this is the equation of the parabola, with vertex 1 by 2 comma 3 by 4. So, x minus h whole square is equal to 4a into y minus 3 by 4. Okay, na? So, this is the equation of the parabola. Here 4a is equal to 1, therefore, a is equal to 1 by 4, right. Parabola equation with the vertex and it is over and y coefficient is here, you are getting a positive. So, this is an upward parabola. Okay. So, let us draw that parabola, let us see what happens. So, this is x axis and it is a y axis. So, this is 0, 1, 2, 3, so on, and this is minus 1, minus 2, minus 3. So, here 1, 2, 3, 4. So, this is a, okay, no need of down, right. Why? Because it is an open upward parabola. Let us see that where is the vertex 1 by 2 comma 3 by 4. So, this is a 1 by 2 comma 3 by 4. So, this will be roughly, so this is your y is equal to x square minus x plus 1 graph. Now, I want to here your y value. So, this is total y is equal to step of x square minus x plus 1. From 0 to 2, I have to observe the from 0 to 1. Why? Because this is total y value, no? Total y value. So, from 0 to 1, 1 to 2, 2 to 3, what happens? Okay, na? Let us see that. Let us see here, if it is y is equal to 0, here y is equal to 0, it does not have any real roots. So, you have complex node. If it is a y is equal to 1, let us see what happens. If it is y is equal to 1, let us see what happens. So, this is equal to x square minus x plus 1 is equal to 1. Therefore, x square is equal to 0. So your x value is x minus 1 is equal to 0, therefore x is equal to 0 or 1. Okay, now if your y value is 2, let us see what happens. If it is your y value is 2, x square plus x plus 1 is equal to 2. This implies x square minus x minus 1 is equal to 0. X square minus x minus 1 is equal to 0. Therefore, your x value is quadratic equation minus b plus or minus root of b square means minus 1 whole square plus 4ac, that means 5 by 2. So, your x value is that 1 plus or minus root 5 by 2. Let us check y is equal to 3 also. Actually 0 to 2 we have to check. Okay, 0 means it will get there is no real roots. Let us check for 3 also. If it is a 3, what happens? X square minus x plus 1 is equal to 3, that is x square minus x minus 2 is equal to 0. Okay, now then what are the roots? This is x minus 1, x plus 1, x minus 2 is equal to 0. Therefore, x is equal to minus 1 or 2. So, these are the x values. That means when x y value is 1, x value ranges from 0 to 1, 0 to 1. It ranges from 0 to 1. That means here it is a 0 to 1. If it is x value y is equal to 2, x ranges from 1 plus or minus root 5 by 2. That means if it is x is equal to 2, 1 plus or minus root 5 by 2 means what? It is something less than 2 only. So, here you will get values. Here you will get. Okay, na? If it is x is equal to 3, it ranges from minus 1 to 2. So, it is ranges from minus. So, here it will come here only. Okay, it is ranges from 2 this side minus 1. So, this is a range of the values. Okay. Now, let us divide the intervals from 0 to 1, 1 to 2 like that. Okay. So, let us continue the solution. Welcome to final calculation. Let us divide our interval from 0 to 2 like this. Okay, now from 0 to 2 I will divide this interval. So, our function is from 0 to 2, 0 to 1, 1 to 1 plus root 5 by 2, to 1 plus root 5 by 2 to 2. So, that means 0 to 1 dx. I will tell what is the integrand, how we will get, that is y value. Again 1 to 1 plus root 5 by 2 dx plus 1 plus root 5 by 2 to 2 dx. Now, what we have to write down the integrand here? What we have to write down? Here, 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 what we have to write down? Let us see this. See here from 0 to 1. So, here this interval 0 to 2 belongs to the x variable of integration. Your variable of integration ranges from 0 to 2, then you have to find out the range of this total function y. Okay, na? Right. Let us see this. If it is 0 to 1, let us observe the graph here. See the graph here. It lies between 0 to 1. It lies between 0 to 1 or not. So, this is y values. All our y values lies between 0 to 1. So, therefore, what is that means x square minus x plus 1 ranges from 0 to 1. What is the inside? Whatever may be this inside, it is ranges from 0 to 1. What is step of the interval 0 to 1? It is simply 0. Okay. Let us see that 1 plus 1 to 1 plus root 5 by 2. So, your x value, according to that your y value is, this is your y value. That means x square minus x plus 1, it ranges from 1 to 2. It ranges from 1 to 2. That means what is the step of from 1 to 2? This is a 1 dx. Okay, na? Right. From 1 plus root 5 by 2 to 2. See here, your y value ranges from 2 to 3. That means it is 2 to 3. Y value ranges from 2 to 3. What is step off from 2 to 3? Whatever by the integer or real numbers from 2 to 3, it is a 2. That's all. The problem is over. Now there remains calculation part. So this is 0. So this is equal to x. Upper limit x means 1 means x. So this is a 1 plus root 5 upon 2 1 plus 2 take common outside x 2 1 plus root 5 by 2. Understand this? Okay. So let us see the calculation. So this is equal to 1 plus root 5 upon 2 minus 1 plus 2 into upper limit 2, lower limit 1 plus root 5 by 2. Okay, na? So let us check here. 2 ones are 2. So this is a root 5 minus 1 by 2 plus this is a 2 into 2 2s are 4. 4 minus 1 3. 3 minus root 5 by 2. 2 2 cancel. LCM 2. So 2 3s are 6. Minus 1 plus 5. 6, that is equal to 5 minus 2 root 5 plus root 5 root 5. So this is your final answer, 5 minus root 5 by 2. See here, very easy problem to understand this. First we divided the interval x interval 0 to 1, 1 to 1 plus root 5 by 2, 1 plus root 5 by 2, 2. According to your x, y value, x square minus x plus 1 ranges from where. So this can be solved using the graph only. So if you draw the graph, the problem will be very easy. Okay, na? So dear students, I hope that you enjoyed today's class. With some more problems, I will come tomorrow's class. Until then, all the best.